So far, we have studied how ionic bonds are formed, what are ionic compounds, and we can deduce the formulas of ionic compounds if we are given their respective ions. Alright, we know how to balance the charge while forming the compound, while forming the structure, or while forming the formula of an ionic compound. Okay, now once the ionic compounds are formed, let's see what are their properties and what are their physical properties of ionic compounds, how do they look like and how do they behave in environment. All right, number one is ionic compounds, they usually form crystals or giant ionic structures. What does that mean? For example, you have seen the crystals of NaCl, the common salt. It exists in crystalline form, all right? So those are the crystals of ionic compounds, all right? They exist in crystal structures. They have crystal structures, and the second property is they are always solids at room temperature. No matter what ionic compound you see at room temperature, it will always be a solid. There will be no liquid or gaseous ionic compound. All ionic compounds are solids at room temperature. Why is that so? You'll soon see. They have high melting and boiling points because of their strong ionic bonds and because of the strong intermolecular forces, or because of the electrostatic forces of attraction. All the ions are held very strongly together with each other, which results in strong melting and very high melting and boiling points. All right. Now, these ionic compounds conduct electricity when they are molten. Why? Because what is electricity? Electricity is the flow of charges. Electricity is the flow of current, the flow of charges, flow of electrons or flow of ions. Now, when ions or when ionic compounds are in the form of solids, their ions are fixed. They are merely vibrating. They are not moving literally. They do not have this translatory motion. They only vibrate at their fixed position. For example, this is a crystal. The ions will only move in their fixed positions. They'll only vibrate in their fixed position. They cannot leave their places. But once they are molten, they lose their crystal structure and they become liquid and D-shaped. They can now flow over here and there. The ion, they do not have those intermolecular forces, or they do not have these bonds. They are free to move. Now, once they are free to move, then they can conduct electricity. All right, and they can also conduct electricity when they're dissolved in water, because that is when they're also free to move. So basically, for the electricity, for we need to have a flow of charges, and obviously we cannot achieve that flow if ionic compounds are solids, because they have their fixed structure. Their ions are not mobile. That is why they do not conduct electricity when they are solids, but they do conduct electricity because they have ions. Ions have charges, and those charges can flow only when ionic compounds are molten or they are dissolved in water, let's say. Then they are conductors. Ionic compounds are conductors when molten or when dissolved, but they are not conductors when they are in their solid state. Molten or dissolved, dissolved, dissolved. Okay. They have strong ionic bonds. All right, ionic compounds obviously have strong ionic bonds. That is, their ions are strongly bonded slash attracted to one another. Have a look over here. These golden circles that I've drawn, they represent sodium ions, and these gray circles that I've drawn, they represent chloride ions. All right, this is a crystal of sodium chloride. This is something, this is how it looks like. This is somewhat how it looks like. Yes, it is a cube, it is a crystal, and this is how the ions are arranged. Look at this. One sodium atom, sodium ion, my bad, one sodium ion is attached to a chloride ion, and this is also attached to chloride ion over here, And now this chloride ion is attached to a sodium ion over here, and this sodium ion is again attached to a chloride ion. Alright, this chloride ion is attached with the sodium ion. Every sodium ion is attached to chloride ion, and every chloride ion is attached to a sodium ion in every direction. Alright, now look at this. A sodium ion and a chloride ion. This is how one unit of this crystal of NaCl crystal looks like. Note a bean. Have a look at the sizes of positive and negative ions. Can you recall why is sodium smaller than chloride ion? Well, remember how the size of metal atom decreases when they form ions? We saw that in the previous video. You must recall this. Why is the size of sodium smaller, and why is the size of chlorine or chloride ion it is bigger? Alright, metal atoms, they decrease in size when they form ions because they lose their valence electron, and by losing their valence electron they also lose their valence shell. The size of atom is reduced. For example, if this was the size of sodium atom, when it loses its valence electron, it only becomes this. Alright, because it loses one shell, it becomes smaller, it shrinks in size. Okay, now this was one crystal structure. If we zoom out, then this is how a bigger structure of sodium chloride looks like. One row is missing. Yes, like this. Okay, now, okay, leave it. Otherwise, I'll have to change everything else. Now, this is how a bigger crystal looks like. Every sodium atom is attached to a chloride ion. A sodium ion is attached to a chloride ion, and the sodium ion is attached to a chloride ion over here as well, and over here as well. Now, this chloride ion is attached to a sodium ion over here, and oops, this is something wrong. There is something. Wait a minute. Let me redraw this. Now, this is attached over here and to a sodium ion, and this is attached to a chloride ion over here. Now it's good. And this is again attached. This sodium atom is now attached to a chloride ion over here and a chloride ion over here. This chloride ion is attached to a sodium ion over here and a sodium ion over here. Every sodium ion that you see, it is attached with another chloride ion, and every chloride ion that you see, it will always be attached to a sodium ion. You can see that over here. Alright, so this is how a larger crystal grows. Alright, this is one unit over here. Now these are two units, and this is how it keeps growing. This is how the crystal keeps growing. Every sodium atom, it gets attached to another chloride ion. Every sodium ion gets attached to another chloride ion, and every chloride ion then gets attached to a sodium ion, and this is how it keeps growing. Now if we want to draw another unit, we'll have to extend it over here like this. Something like this, yes. Now we have a chloride ion over here, and it will be attached to a sodium ion over here. We have a sodium ion over here. Now it will be attached to a chloride ion over here, and this will be attached to a sodium ion over here, and then here will be a chloride ion again, and then here will be a sodium ion again, and a chloride ion over again. So you see, again, one sodium atom is attached to a sodium ion is attached to a chloride ion, and chloride ion is attached again to a sodium ion, and then a chloride ion, and then a sodium ion. So that is how it keeps growing. Alright, this is why they form giant crystal structures. They are continuous crystals, they keep growing, and they form giant ionic crystal structures. In such a lattice, millions of sodium and chloride ions are arranged in an orderly manner. This is the orderly manner that we're talking about. One sodium ion being attached to another chloride ion, another chloride ion being attached to the next sodium ion. Alright, so this is how this order follows to the millions of ions. And they're held together by strong ionic bonds. Alright, now this is positive, this is negative, this is positive, this is negative. Now these are all strong ionic bonds in between them, strong intermolecular forces, strong electrostatic forces of attraction between these positively and negatively charged ions. There's one thing important, you'll notice that in a larger crystal, number of sodium ions, it always equals to the number of chloride ions. Alright, if you look at this one unit, there are one, let me change the color, I'll do this. There are one sodium ion, two sodium ion, three sodium ions, four sodium ions, and the number of chloride ions is also the same, one, two, three, four. Alright, so the number of sodium ions, it always equals the number of chloride ions in a crystal of sodium chloride or in any other crystal of an ionic substance or an ionic compound or in an ionic structure. That's it for now. I'll see you in the next video.